so if I were graphing this, the first thing I would do is write this in factored form. Now the bottom is already fully factored. The top I can unfoil. Looks like I'm going to want x plus 2 times x plus 5. That way outsides give me 5x, insides give me 2x, they combine to give me the 7x, and my last terms multiply to give me the 10. Okay, no factors in common on top and bottom, so I can't reduce this, it's already in lowest terms, and that tells me that there are no holes in the graph. Okay. I do want to always check for that. I know we've only seen one example with that, but I've checked every single time. All right, I like to start with what's not in the domain. What would make the bottom 0? -3. And since it makes the bottom 0, even when we're in lowest terms, that's going to be a vertical asymptote. Okay, excellent. Let's see, let's get some intercepts. If I look for the y-intercept, that's going to be 0, f of 0. F of 0 is just 10/3. Again, if I use the multiplied out version of things, all the x's just go away, I get 10/3. Notice 10/3 is 3 1/3, so when I graph that, it's going to be a little higher up than 3. Okay, let's get our x-intercepts. So f of x would equal 0, would mean that x plus 2 equals 0, or x plus 5 equals 0, provided that the bottom isn't 0, so that x isn't -3. Not going to cause any problems there, because this would give me x equals -2, or x equals -5. So I'm going to have two x-intercepts, -2, 0, and -5, 0. Excellent. Right now, I can see there's no symmetry. Okay, I could have actually seen that as soon as I saw that there was an asymptote on one side and not the other. Okay, so no symmetry for this particular graph. Let's take a look at the end behavior. So I know we're looking at our lead term, fraction of our lead terms. More x's on top than on bottom. So the end behavior, I know we're going off to infinity or -infinity. Is this the special case that the degree on top is 1 more than the degree on bottom? Yes. So we have a slant asymptote. If the degree on top was 2 more than the degree on bottom, or 3 more, or 4 more, or some other number more, we'd still be going off to infinity or -infinity. We just wouldn't be approaching a line as we did that. It would continue to really curve significantly. All right, so I know that there will be a slant asymptote. I would like to find the equation for that slant asymptote. To do that, I do need to look at more than just the lead terms. Looking at them tells me there is a slant asymptote. I need to actually do this division problem to see what the equation of the slant asymptote is. Because the denominator is just 1x plus a number, I can use synthetic division. So we've got 1x squared, 7x, 10, constant x squared, good. X plus 3 is the same as x minus -3. So -3 is the number that goes out here. Bring down the 1. Multiplying gives me -3. Adding, I get 4. Multiplying gives me -12. Adding, I get -2. That's my remainder. So I'm able to say that f of x is equal to x plus 4 plus a -2 over x plus 3. This piece, the remainder over what we were dividing by, that goes to 0 as x goes to infinity or x goes to -infinity, which means that's the equation for my slant asymptote. So that's going to be a line whose y-intercept is 4, slope is 1. So I'll draw that in as a dotted line. Notice that we'll cross the x-axis at -4, 0, because that's what would make my y value 0. Okay. So I want to be careful when I'm drawing things. I'm not expecting your graphs to be perfectly to scale, but to make sure that that asymptote crosses here in between this x-intercept and this vertical asymptote. Okay, excellent. So I think we've covered all of the important points. There weren't any holes. We've got the vertical asymptote and we've got the slant asymptote to give us the end behavior. So it's time to play connect the dots. Let's see. I'll do it over here. I'm going to mark off on my number line the places where my function could change sign. That's at -5 and -2, my two x, the locations of my two x-intercepts, and also at -3. Whoops, -3 comes before -2. So at the location of the x-intercepts and at the location of the vertical asymptote. So to the left of -5, I can tell we've got to be negative because we've got to be close to this line, and the y values on this line are negative on that part of the plane. Okay, between -5 and -3, I don't actually have any information there, so I'm going to need to pick a test point. Let's just pick a -4. If I plug in a -4, this will be negative. X plus 5 would be positive. This would be negative. Two negatives and a positive are going to make it positive. So we will cross above the x-axis here. Okay, between -3 and -2, I don't have any information. So let's check. We'll plug in -2.5, which would be -5/2. -2.5 plus 2 would still be negative. Plus 5 would make it positive, so we've got a negative times a positive. -2.5 plus 3, that would be positive because 3 is bigger. So we just have one negative sign, so that's going to make that negative between -3 and -2. And then to the right of -2, we're going to be positive for two reasons. One, we've got to pass through that point, and two, we've got to approach that line. Okay, so to the left of -5, I know I need to start out very close to this line. And we're going to come up and pass through that point. We said we were going to become positive then as we approached -3. So that tells us we're positive here. We've got to be going off to positive infinity. Because as we get closer to -3, we're either going really high up towards positive infinity or really low down going towards negative infinity. So this one's going to go up like so. Between -3 and -2, we had to be negative. So since that's to the right of this asymptote, we've got to start down really low. We're going to come up and hit that x-intercept. And then we cross the x-axis. We're going to become positive. We're going to pass through that point and approach that asymptote. So it's going to look something like so. Again, I find it really helpful to have this number line where I mark off the zeros, that's the x values of the x-intercepts, and the vertical asymptotes. And I just focus on those intervals because it's at the zero, it's at the x-intercepts and at the vertical asymptotes that my function could change sign. Particularly when I have a slant asymptote, this graph looks kind of busy. This allows me to really just focus my attention. Okay, I'm looking to the left of -5. Now I'm looking between -5 and -3. All right, so that gives us our graph of this particular function. I want to just review one thing very quickly. We talked when we first introduced asymptotes, we talked about how we could use the arrow notation for our vertical asymptotes. And we've really been focusing on just getting the graph. But there are definitely some homework problems that just ask you to describe either the end behavior using your arrows when you have a horizontal asymptote, not so much with the slant asymptote, but if you've got a horizontal asymptote, we've been using the arrow notation, but with this vertical asymptote, I can also describe things. Notice, as we approach -3, on one side we're going up towards infinity, and on the other side we're going down towards negative infinity. Let me just remind you how we would denote that. I would say as x approaches 3, when I put a superscript of a negative sign, that's saying I'm coming from the negative side of my number line, that's coming from the left. Coming in from the left, we're going up, so I would say f of x goes to infinity. Then to describe the behavior coming in from the right, as x goes to 3, I would put a superscript of a plus sign to indicate that we're coming from the positive side of the number line, or from the right. F of x is going down, so towards negative infinity. Now, stating this is not part of drawing the graph. You're indicating that graphically when you're drawing the graph. So if you say, oh, I didn't remember to do that, you didn't forget anything. I added this on to the problem after we'd finished drawing the graph. If I want you to describe the behavior using arrow notation, I will explicitly say that. I just wanted to review this because we talked about this at the beginning of this chapter, but hadn't used this notation a lot since then, and it does definitely show up in the homework. And it's just a little bit new because we've got those superscripts to indicate what side we're approaching the number from. All right, excellent.